Hi there, my name's Cameron. In this video I'll be showing you how the accelerometer was constructed and just to let you know the progress of this part so far. The part purchased was Analog Devices 3-axis accelerometer that is driven by a microcontroller, where the microcontroller reads the analog to digital conversions that this accelerometer puts out, and therefore the microcontroller can give the user a clear output of the tilt of the unit using trigonomic functions. Now, the accelerometer has a refresh rate of approximately 5 Hz a second, 5 Hz, and it can also read up to the G-forces of 6 Gs. Now, this part was used in the Nintendo Wii, so there was a lot of help and source code out there available, but it was pretty much easy enough to be done straight off the bat. Now the parts used in this device consist of a accelometer1 microcontroller to drive the accelerometer, and this code can easily be ported back to the USB accelometer that we will be using. I just used the accelometer1 just for debugging purposes. It's a lot easier, and once I have the base software up and running, it's easy just to port straight over. Now, just to introduce you to the hardware, this is my lovely development board I've been working with. As you can see, there's the accelerometer there, the chip there with the pulses of the data being read. Okay, microcontroller here, alright, and an LCD screen just so that I can read values in real time coming from the device. Here we have the X value, the Y, and the Z. Now, if I tilt the accelerometer on the X value, the X and the Z value should change, but the Y should stay the same. Okay, so as I do that, my focus plays up, and you can see the X and the Z changing dramatically. Okay, now I'll let that settle again. Alright, and there you have a basic readout from the system. Now, on the left hand side here, let me just move this development board, you can see my awesome trigonomic functions there trying to generate some form of G-force readout. Okay, I've got up the top here -2, which seems to be changing a lot from -2 to 1, and Y, I seem to have a problem with my maths calculation on the microcontroller, but I haven't spent too much time on it. It was a quick 30-minute put together for that algorithm, but it obviously doesn't work. So there you have it. Problems that I did encounter while designing this project were the reference voltage that the microcontroller runs off. Now, when it takes a sample and hold value from the accelerometer outputs, okay, and it holds the value there, and it needs something to reference them to. So what I did is I used the VCC voltage, which is 3.2 volts, coming from the accelerometer, and use that as my V reference. Okay, now that seemed to fix everything because I was originally using a reference voltage of 5 volts, and for some reason I just couldn't get it to calibrate properly. And once this reference voltage was fixed, everything seemed to fall into place. Another issue, as you saw, is the trigonomic calculation. Okay, now this I will have to look into a lot more, but what it will do for me once I've completed it is tell me exactly what angle of tilt that the device is on, so that this reading can be sent back to the user, and it can be determined if it's about to roll over, or yeah, something like that at least, just to give the user more information on what kind of environment that the machine is actually at. So yeah, enjoy.